Today we're going to talk about principal values of trig functions. So this is section 6.5. And it's called principal values of inverse trig functions. And the whole idea with this is we're going to try to figure out how our calculator is coming up with the answers that it does whenever we type in inverse trig. So inverse sine of 1/2, why does it say what it says? Why doesn't it give us both values? So let's start with sine. For the graph of sine, we're going to do this for sine, cosine, and tangent. What I'm going to do is I'm going to copy and paste this just so I don't have to draw it 3 times. So for the graph of sine, you guys know that the graph of sine looks like this. It's a wave, sine of 0 is 0, 90 it's 1, 0, -1, 0. And we could just keep that pattern going. And if we connect the dots, get a wave that looks like that. Now if we were going to graph the inverse, so let's say we are graphing theta is equal to the sine of y, what we're doing is we are switching the x and the y axes. So we're going to have 1 here, we're going to have -1 here, 90, 180, 270, 360. And I'm going to also copy and paste this 3 times so I don't have to draw it separately. All right. Should get everything lined up for us. All right, there we go. So if we were to graph the inverse sine, it would look like this. Still a wave, but we're going to be going vertically. 0, sine of 90 is 1, 0, -1, 0. Sine of -90 is -1, 0, 1, 0. Connect the dots. And we get a graph. Excuse me. We get a graph that looks something like that. Now the problem is this isn't a function. Your calculator is only programmed to figure out functions. So if I asked you what is the sine of 1/2, your calculator is going to want to go, okay, 1/2 is right here, but I can't possibly give you this value, and this value because calculators are only programmed to give one value. So we have to modify our graph to only give us one function or to make it into a function. In order to do that, what we're going to do for sine is we're going to restrict the inverse just from this graph right here. That highlight means that whenever we ask our calculator to find the arc sine, that means that theta, or our calculator, only gives us values between negative 90 degrees and positive 90 degrees. That's the domain of the arc sine. Now we could do the same thing with cosine and tangent. The main idea here is that you know the domain of arc sine. We'll graph cosine of theta, and we'll graph tangent of theta. And then we will graph their inverses. Okay, so to graph cosine, we know it starts at 1, 0, negative 1, 0, 1. And we could just finish out the graph. That's what the graph of cosine looks like. And then if we draw that for the inverse graph, where we switch the x and the y axes, we can connect our dots, connect our points, and you can see that the graph of the inverse cosine is not a function either. We restrict the domain from 0 degrees to 180. That little sliver of the graph is what the graph of the arc cosine looks like. And what you have to remember is that the arc cosine has a domain from 0 degrees to 180. We'll do the same thing with tangent. We know we have asymptotes at negative 90 and 90, and every 180 degrees later. And in between we have a cubic function. If you're not sure where these are coming from, you could watch a previous lesson for graphing trig functions. That's what that looks like, and if we were to reflect it over it's a little bit hard to see, but the graph of the inverse tangent would look like this. So I'm just I'm taking the reciprocal, or I'm switching the x and the y axes. Now, for arc tangent to be a graph, we just have to take one of these branches. And that branch would have the domain between negative 90 degrees and positive 90 degrees. We can't include 90 or negative 90 because those are the asymptotes, and we know that there's no value on those asymptotes. Bottom line is these are called principal values, or these give us the principal values of trig functions, which is what our calculator gives us. That's how they're programmed. So let's take a look at some examples, and I'm sure you'll understand. So I'll ask you to evaluate. What is the arc sine of, let's say, 1/2? Well, we've done this kind of thing in a previous section. We know that in order to get a sine of 1/2, we know that that comes from a 30, 60, 90 triangle. We get 1, 2, and root 3. So the sine of 30 degrees would absolutely work. In the last section, we remembered that all students take calculus, and we would have also drawn 1/2 in this quadrant also. So we would also draw 150. This was in the last section when we were talking about inverse trig functions. This says arc. So because that says arc, we're only looking for theta between -90 degrees and +90 degrees. So the only answer that we would take is 30. If you were to type into your calculator inverse sine of 1/2, inverse sine of 0.5 in degree mode, your calculator would say 30 degrees because that's within the domain of the arc sine function. What about a problem like this? What about the tangent let's do it like this. Let's say the arc tangent of the sine of pi over 2. Okay. Now, the way that we would do a problem like this is, what is the sine of pi over 2? Well, the sine of pi over 2, it's not going to give us an angle, right? Regular trig function just gives us an answer like 0, 1/2, 1/3. So let me write that down. So regular trig gives like a side or a ratio, and inverse trig, inverse or arc trig, gives an angle. So this one, the sine of pi over 2 is 90 degrees, and the sine of that value right there, sines the y value, that would be 1. So this question is really asking you, what's the arc tangent of 1? Well, arc is going to give us an angle, and I know from my 45, 45, 90 degrees that that the inverse tangent of 45 is 1 over 1. So in a previous section, we would draw the 45-degree answer, but we would also put this where else tangent is positive. All students take calculus. We would draw that right here. We would say that the answer is 45 and 45 plus 45, which is 225. Now, because this was an arc tangent, we don't want both of those answers. If you go back to what we said from the graph, tangent is only defined from -90 to 90 right here. So we're only going to pick the answer between -90 and 90. And that would mean just 45. If you were to type this into your calculator, that would be the answer that you would get. And type this in, and that would be the answer, 45 degrees. We'll do one more, and then I'll give you your homework. What about the cosine of the arc tangent of root 3 minus the arc sine of root 3 over 2? Okay. Well, this is asking you, when is tangent root 3? Well, I know that that comes from a 30, 60, 90 triangle. And if this was 30, this would be 1, 2, and root 3. So this would be 60. The tangent of 60 is root 3 over 1. Arc tangent means we're just looking between -90 and 90. So that first piece, or that first angle, would just be 60 degrees. Now, what's the arc sine of root 3 over 2? Well, that would also be 60 degrees. Look at the triangle we just drew. The inverse sine of 60 is root 3 over 2. We're not going to draw it in another triangle because sine is only defined from -90 to 90 degrees. So we just want the one in quadrant 1. So that would be 60 degrees. So to finish this problem, we're going to do the cosine of 0 degrees. That we're going to get from our quadrantal angle. Cosine of 0 is the x value, which is just 1. Remember, the x value is the cosine, the y value is the sine. For homework, I'm going to ask you to do practice 6.5. I would like you to please do numbers 1 through 15. Thank you very much. Have a nice day.